Hello guys, welcome to Learning with Lai. Today's video is going to be about speed and velocity. We must have all seen an object or body moving and notice that it is either moving faster than we are or slower. This makes a term pop up into our mind that the object might have a speed. We vary or look at the distance covered by the object or body over a certain period of time. So let's take for example two kids. I have the first kid here named A, and I have the second kid B, and two of them are running on a track. A now finishes first while B takes second position. So now we can now conclude that A has a faster speed than B because he finished the race at a shorter time. So, but during the race between these two kids, A might be conscious that B is catching up to him and begin to run faster. This might occur frequently, resting a bit and increasing his pace till the end of the race. If we are to consider the time taken for the race, we should have an idea of the average speed for each of the children. So if we're talking about average speed, let's take the winner who won the race. Imagine he might be running at a certain speed of, let's say, 10 meters per second. Then he now looks back and notices that B is catching up to him. He might increase his speed to be 12 meters per second. Later, he might relent again. His speed might drop back and he have 11 meters per second. And also, he might be feeling that he has almost won the race and his speed could drop to 9 meters per second. So when we want to try and look at, because during the race, he was not running at a certain speed throughout the whole race. Maybe like he ran for the first 5 minutes of the race, or 5, depending on how long the track is. So he ran maybe for 10 meters per second, later increased the speed when he was conscious that B was trying to catch up to him, and excuse me, and later on increased his speed. He reduced the speed rather to 11 meters per second, and also when he saw that he has almost gotten to the finish line, he also reduced the speed to 9 meters per second. So if we're trying to look at the average speed of this, we're going to divide all of this by 4, and our answer would be 10.5 meters per second. So this is the value for his average speed. So we can see it now. But same also when we're driving a car, having to obey traffic rules and regulation might cause one to change speed or stop to consider the whole time for the journey. And that's why we have this term average speed, not only having speed alone. So that means for the whole journey for that car moving, obeying the traffic laws, must have an idea of what we call average speed, because the car can't be moving at a certain speed. It might be changing speed because of the traffic rules or other incoming vehicles. So speed is now defined as the rate of change of distance moved with time. So the definition of speed is the rate of change of distance moved with time. So since we have rate of change, that means we're starting from a certain position and we're finding ourselves at a different position. So that's when we have a change. So, and we can have the formula to be written as average speed is equals to distance covered over time taken. And now if we take for instance a car or object that moves a distance of 50 meters over a certain period of time, which is 20 seconds, and we're going to have our final answer to be 2.5 meter per second. So that's a kind of straightforward question. Similarly, I have another example. If we have a car takes 2 hours to drive along a bumpy road from town A to town B, 54 kilometers away, what is the average speed of the car? So since we have our formula, average speed is always equals to distance traveled, or we can write it in short, distance over time. And we know our distance from the question given to be 54 kilometers, and we have our unit of time to be in hours, and this is 2 hours. Our final answer is going to be 27 kilometers per hour. So we can always note that the SI unit for speed is given as is meter per seconds or kilometer per hour. So it depends on which unit of distance is given and unit of time that is given in the question. So it might come to your mind that what is the real value of speed or actual speed of a moving object? So for us to determine or measure the actual speed of any object, or we also call it the accurate speed. So the actual speed of an object, the distance moved by the object is to be measured in a very short interval of time. So distance moved by the object is to be moved at a very short period or interval of time. Let's take for example now, if we have a tennis ball being struck or served, or a golf ball. So being struck or served, since the time interval is short, there is less likelihood that the speed will vary over the measured distance. Otherwise, the value obtained will be an average speed. So when we're trying to look at the distance moved, let us see if we have the distance moved over time. If we moved a distance of 10 meters in 2 seconds, we're going to have the speed of the object to be 5 meters per second. So we can see that we moved in a very short period of time. Even this 2 seconds is much, maybe in a microsecond, because if we even look at the variation between speed and time, speed let me write it, speed is equals to time. So, and if we look at the variation between speed and time, we have an inverse variation. That means when time is very small, we should have a very high value of speed. So that means for us to determine the accurate value of speed, we have to measure it over a very short period of time. So before I talk about velocity, although velocity is having the same unit as speed, but they are different quantities. From my video about scalars and vectors, we saw that speed and velocity is different because speed is a scalar quantity while velocity is a vector quantity. So, and they both have the same unit, meter per second or kilometer per hour, while the same thing, meter per second or kilometer per hour. So let's take an example. If we say a car travels a distance of 100 meters, it wasn't stated the distance of the car which moved 100 meters, or it wasn't stated that it moved in a specific direction, so which makes the distance a scalar quantity, because if you look at scalars, they don't have direction, but when we're talking about vector quantities, they always have direction. You can check that in my scalars and vectors video. So speed is also used when a moving object changes its direction. So that's why we can use the term speed when there's always a change in the direction. But when there's no change in the direction, if the car is moving in a specific direction, then we're going to have velocity, then not speed of the car. So if that same car moves along a straight line or constant direction, or either due south or due west, or in any of the cardinal point, either south or west, the direction was stated and we are no longer dealing with distance of the car but displacement of the car. So we can see that this is the term differentiating speed and velocity. Distance for speed, while displacement for velocity. So, and this is in a specified direction. Due west, east, or etc. So velocity is not therefore defined as the rate of change of distance moved in a specific direction. So velocity is the rate or change of distance moved with time in a specific or specified direction. Or we can also call it the rate of change of displacement moved with time. And we have the formula for velocity. Velocity is equals to displacement over time taken. And can also have it to be distance moved in a specified direction, and it also equals to distance moved in a specified direction, which is displacement over time taken. And we've seen it that the SI unit for velocity is in meter per second, the same as speed. So SI unit is the same as speed. So suppose a car takes, we have an example here, some on velocity. Suppose a car takes 9 seconds to travel along a perfectly straight road, PQ, 270 meters long. What is it? Average velocity. So from here now, you can see that from the formula of velocity, we have it to be displacement over time. And this is going to be, since we already know it moves perfectly straight road, and we can see this is a bumpy road, so the path for this bumpy road could be like this. So we can see it's not moving in a straight line, but whereas we have a perfectly straight road, so this is in a specific direction. This is distance and this is displacement, a straight path. So we have our distance, our displacement rather, to be 270 meters all over 9 seconds, and our final answer is going to be 30 meters per second. So thanks for watching, and please subscribe.